welcome back to The Explainer. I am absolutely thrilled to have you here today because we're going to dig into the very DNA of successful technology. We are talking about the software development lifecycle, the SDLC, and we're going to zoom right in on its most absolutely critical phase, the preliminary investigation. If you've ever found yourself wondering how massively complex software goes from just a vague, hazy idea in a boardroom to a flawless application running on your phone, well, you are exactly in the right place. Let's get right to it.
So think about this for a second. Why do software projects fail? It is a massive, massive issue across the tech industry. I mean, we constantly hear about apps crashing on launch day, right? Or projects that go millions of dollars over budget. Or worse, systems that take literally years to build, only to end up being completely unusable by the client. And what happens? Everyone just reverts back to using their trusty, chaotic spreadsheets. Now here's the thing. These failures almost never happen because the programmers suddenly forgot how to write code. No, they happen because of poor planning, budget overruns, or just a sheer lack of quality control right from day one. That sets the stakes for us today. To avoid all of that chaos, we absolutely need a structured blueprint.
Okay, let's dive right into this. Here's our roadmap for today. We're going to start wide by looking at the chaos problem and the SDLC framework as a whole. Then, we'll zoom in on the preliminary investigation, where we'll cover finding the real problem, defining the scope and costs, and finally reaching the final verdict. And we're going to use a continuous real-world case study to anchor all of this together. All right, kicking things off with sections 1 and 2, the chaos problem and the SDLC framework. This is where we lay down the primary solution to all that disorganized, high-risk development we just talked about. So what actually is it? The software development lifecycle is a systematic process used to plan, develop, test, deploy, and maintain software systems. I want you to visualize this as a master flowchart. User requirements enter at the very top, the data flows logically down through distinct connected phases, and a polished, functioning product pops out at the bottom. The core purpose here is strictly about developing high-quality software on time, bringing down development costs, and, most importantly, actually meeting the customer's real requirements.
And when a team actually commits to this systematic flow, the benefits are just undeniable. We're talking about better project management, much higher software quality, drastically reduced risks, strict cost control, and ultimately real customer satisfaction. Plus, it forces proper documentation along the way. You know that iron triangle of balancing quality, cost, and time? Trying to manage that is practically impossible if you're just winging it. The SDLC forces discipline. It turns what could be a chaotic art form into a highly reliable science.
The life cycle itself flows logically through 5 major steps. It kicks off with the preliminary investigation, flows right down into requirement analysis and design, moves into development and testing, rolls out into the real world during implementation, and finally settles into long-term maintenance. Picture the data moving from a really abstract problem in step 1, transforming into concrete system blueprints in step 2, becoming actual, compiled code in step 3, and turning into a live, breathing product by step 4. It's this elegant, continuous flow. Having this high-level blueprint in your head is vital before we zoom in closer. Let's move to section 3 and see how this builds. We are jumping into the preliminary investigation. This is the very top of our flowchart. The preliminary investigation is the absolutely critical first phase of the whole SDLC. The entire purpose here is to just stop and look at the existing system, identify the actual problem, understand what the organization truly needs, define the project objectives, and honestly, determine whether a project should even proceed in the first place. Because before you invest massive amounts of time, cash, and developer resources, you absolutely must understand if the software solution you're dreaming up is actually viable.
That brings us perfectly to section 4, finding the real problem. To really grasp this, we're going to follow a real-world case study. Imagine a really large, bustling college, okay? And they are severely struggling with a manual, paper-based college management system. Attendance is still taken on paper, physical records are getting lost left and right, and end-of-semester reports are just endlessly delayed. It's total chaos, right? What's really fascinating here is how simple but penetrating these next 4 questions are. This is Activity 1, Problem Identification. Before we let anyone write a single line of code for this college, we have to ask, what exactly is the problem? Well, records are delayed. Okay, why does it exist? Because manual data entry takes way too long. Who is affected? Teachers, students, and administration. And finally, how serious is it? It's incredibly serious. It's literally impacting funding and grading accuracy. By rigorously answering these 4 questions, we define exactly what needs solving. We take a vague complaint and transform it into a highly targeted mission.
But here's the catch. You can't just guess the answers to those questions. You need hard data. To get it, a system analyst relies on various specific fact-finding techniques: interviews, questionnaires, observation, document review, and discussions. Imagine an analyst actually sitting right there in the college's admin office. They're observing the staff furiously sifting through physical filing cabinets. They're interviewing teachers who are complaining that it takes 20 minutes just to manually log morning attendance. They're reviewing the actual physical paper documents to spot the bottlenecks. They are actively mapping out how data flows, or rather gets stuck, in the current manual workflow to fully expose its weaknesses.
So, the crucial point is, once we've finally identified the real problem and gathered the facts, we have to contain it. That brings us to Section 5, defining scope and costs. Defining the project scope is essentially drawing a massive, uncrossable line in the sand. We rigidly compare the boundaries of included features versus excluded features. For our college case study, an included feature is building an automated student attendance system. An excluded feature? Maybe an automated payroll system for the janitorial staff. By explicitly defining these boundaries incredibly early on, we prevent what the industry calls scope creep. It stops misunderstandings with the college administration dead in their tracks, and it keeps the development team hyper-focused on solving the primary problem.
And this brilliantly illustrates the next mandatory step, the initial cost-benefit analysis. On one side, we estimate the expected costs for the college: purchasing new servers, database software licenses, and of course, the actual developer hours. On the other side, we map out the expected benefits: drastically improved efficiency, massively reduced data entry errors, and hundreds of human hours saved every single semester. By weighing these 2 columns against each other, the organization can mathematically determine if developing this automated college system is actually a sound financial investment or just a money pit.
Which naturally guides us right into our final section, the final verdict. This is the moment where all of that research, observation, scoping, and math finally comes to a head. The entire preliminary phase wraps up with these 3 definitive steps. First, we've conducted the thorough investigation. Next, the analyst prepares a comprehensive preliminary report. This single document bundles up the exact problem statement, the rigid project scope, all that fact-finding data, and the initial cost estimates. It essentially synthesizes all that complex workflow data into a really clear, compelling narrative. Finally, this report is handed over for the management decision. The leadership team looks at this blueprint and they have to give a definitive yes or no. Let's actually end on this question, because it's a huge one. What if management reads that report, looks at the costs, and just says, no? Your initial reaction might be to think, well, the investigation was a total failure. But here is the undeniable truth. If a preliminary investigation reveals that a software project is too expensive, too risky, or simply not viable, and management kills it right then and there, that is a massive success. You just saved the organization months of wasted time, potentially millions of dollars, and immense frustration. And honestly, that is the true power of the SDLC. It doesn't just help build great software, it stops bad software before it ever even begins. Definitely something to think about the next time you hit a frustrating glitch in an app. Thanks for joining me on this explainer, and I'll catch you in the next one.